Hey, people. Hopefully you can hear me. I'm Jakub Skłowski. I'm head of infrastructure at Status. I'm going to give you a brief overview of what Status Node is and how to run it, and what kind of automations and documentation we provide for running it. And hopefully we'll have some time for questions and answers at the end. So first thing first, what is a Status Node? It's just a piece of software that facilitates relaying of messages between status peers, mostly mobile and desktop applications, in a way that's private and anonymous, or pseudo-anonymous specifically, in a decentralized manner. Now, Status Node started off as a fork of Go Ethereum, specifically the Whisper protocol, but we quickly realized that it doesn't provide all of the functionality that we need for our nodes, and it started evolving from there. For example, we added things like replying to queries for historical messages, and we also changed or replaced the use of Bloom filters with topic interests with the introduction of Waku v1. And all of these were done either to provide additional functionality or to just improve performance, specifically in terms of bandwidth usage. Now, why would you want to run a status node? Well, the main reason, at least for us, is to make the status network more decentralized. Right now, we run most of the nodes because we do not have any automated infrastructure for incentivization of running nodes in place right now. And that is being worked on right now in Waku v2, but for now, we have to do it manually, like through the node program. And the more people from Status community run their own nodes, the more decentralized the network is, and the less you rely on our own infrastructure. In addition to that, the node program would allow us to essentially monitor how the network behaves with more nodes and with modes of different abilities, different performance, and how it affects performance of our nodes, and as well as bandwidth usage. It can also help us improve the documentation and automation for running nodes, so we can get that up to shape for V2. For you, a benefit might be that you might find that status appears more snappy, because if you run your node in a location near you, then, for example, queries for historical messages will be faster. And also, in a kind of an edge case scenario, if you are in a country that blocks status nodes or status fleet through a firewall, and you have a node that, for example, manages to connect to our fleet through a VPN or something like that, then your node can facilitate communication within the status network in that country if you share the address of that node, the inode. So those are some of the reasons why we would want to run one. Now, where you can find it? Well, Docker images are available, which is probably the simplest way to run a status node. We also have, of course, the repository from which you can build it locally. It's available on github.com in the status-im organization under status Go. We do not provide any release builds right now because cross-compiling Go for status Go is a bit of a pain. But it doesn't build that long, so it's not that big of a problem. We might provide cross-compiled binaries in the future. You'll need a Go compiler or newer than 1.13. I've used 1.16 and it works just fine. But for most, the Docker image would be the solution, unless I guess you want to run on something like an ARM device. We don't provide images for ARM devices, so you would have to build locally from the repository. There's multiple ways you could run the node. The main two ones are either through Docker, or specifically Docker Compose, or using a systemd service. We support those two ways for our scripts and documentation, but you can run it any way you want, really. As long as you build it and you provided the JSON configuration necessary, you can run it however you want. But we provide automation for specifically running it as Docker and the systemd, so that should be simpler for most people. We have several documents available for figuring out how to run a node. There's the mail server markdown file in the repository at the root. There's also how to run a status node in our technical documentation, and a great step-by-step guide by Jinho from marketing, as well as a a document on how to deploy your own EC2 instance. Actually, AWS provides a free instance, which is I think called T2 Micro, which is free for a year. So that's a sensible way to run a status node. Now, the simplest way really is to just clone the status go repository and simply run run mail server docker, which will initialize a bunch of scripts that will configure the node and create a container and give you the address of that container. So let's try that out. I already have cloned the status go repository. I have it here, so we can just do make run mail server docker, and that should generate the config file necessary. And using the Docker compose file that we have available, create the container and then print out the address and the inode address specifically of the new node, so you can use it to connect either a mobile device or provide the address to some friends or something like that, and also to us because we will want to monitor your node. So as we can see, we have generated the config file. The default folder for configuration and data is the status go mail server under var tmp. And we can see the container is running with some ports open, and we have been provided with the inode address that you can use to connect to this inode. Now, what is happening actually when you run this command? Let's take a look at the makefile. Right? We can just grep for it, just additional line in the makefile. You can see that the target is actually very simple. It simply goes into underscore assets, compose, mail server, and just runs make. Let's do that. And this is just another makefile, which is specifically designed to configure the Docker compose setup. It provides several targets that you can use. The default one is, of course, all, which goes for a set of targets that set up the node. And there's several other ones that can give you some additional information about the node. And of course, you can do stuff like print the inode address or regenerate the config. Right. The content of this directory is just the Docker compose file, which defines the container and what kind of argument it will use to start, what kind of ports it will expose, and what kind of volumes it will add. And those are modified by configuration available in the makefile. There's also a README file that details this. So if you take a look at the makefile, we can see that at the top, we just have some basic settings like addresses and ports of service that the node provides. Things like the Docker image that we'll be using, and some of the configuration like the path for the data and the configuration file. If you look at the all target, we can see that essentially just goes for a set of targets and runs those in this order. So first of all, it runs a few checks, and those checks just verify that we have certain tools like Docker Compose or JQ for JSON manipulation. And then it runs start, which simply calls Docker Compose up to create the container. And other than that, it uses show to show you the container is running with Docker PS, and then provides information about the Docker container. In this case, it's just showing a message and giving you the address and the inode, and then printing the QR code of the inode so you can use it with your mobile device. Now, it has some other targets in addition to that, for example, logs. So you can look at the container logs, or in addition to start, it also has stop. So you can use this to manage it. And there's also clean, of course, for destroying the container. It's very basic, and you can do the same things with just using the normal Docker command line to manage the container. For example, Docker PS will just show you that the container is running. Same thing as just make show, right? Except in this case, we're using different format. Also, there's make logs, which simply runs Docker Compose logs with some additional flags. As you can see, our node is running. It's not many logs because it's a pretty fresh node, but you can see it's already having connections to peers. Now, you can inspect this Docker container just using normal Docker inspect. So we can take a look at how it's configured. So, for example, this is just my alias for Docker PS. If you do Docker inspect and the name of the container, you just get a bunch of data in JSON format. Let's just query it for some specific information. For example, we can look at config CMP to look at the flags we've provided, and they should be essentially the same as the ones that we have in Docker Compose. And then we can see metric port was replaced with the port, and log level was replaced with the level as they were defined in the makefile. Or we can, for example, look at the mounted volume. So mounts, you can see that, yeah, we have mounted the config file and the data directory in which the container will be storing the saved envelopes. Now, what kind of ports is this service exposing? There's essentially 3 ports. Well, actually 4 if we count the TCP and UDP of the FTP. There's by default at least, you can modify those ports if you want. By default, there's 30303, which is the DevP2P port, which facilitates messaging. And that's both TCP and UDP, and that port should be always public and should be available from the internet, otherwise your node won't be very useful. There's the JSON-RPC API port, which is 8545. And that port should never be public because it's a management port. It's intended for administration tasks, so it's quite sensitive. And there's also the Prometheus metrics port, which is 9090, and that shouldn't be public, but in theory there shouldn't be any harm in it being public. It just exposes metrics, so it's just read-only. And we can explore those endpoints just to figure out if our node is functioning properly. So, for example, we can query the metrics on the 9090 port. So let's do that. Do curl localhost 9090 metrics. You can see there's a bunch of stuff there, quite a lot of metrics, close to 500. If we want something specific, we can just, for example, grep it and do like, for example, Waku envelopes. Quote. Yeah, and we can see that the node has already received close to 2,000 envelopes. It's not much because the node has just started, but there's some. Or for example, we can see how many peers we are connected to. So we can do like PDP peers. As we can see, we're connected to 3 peers, version 079. And that should, in theory, grow. Although we have had some problems with discovery, which we will be addressing. So we might have to ask you in the future to upgrade your nodes. But for now, it should be working anyway based on the nodes it connects to by default, based on the configuration. The other way you can interact with your host, with the node on your host, is the JSON-RPC API. And you can call that with curl, as I did with the metrics endpoint, but that's a bit cumbersome because you have to provide some flags, and it's not very friendly. So we provide a script under assets scripts, rpc.sh, and that allows you to call RPC by just providing the method. So for example, we can call, I have to go up because I went into the folder for the specific makefile. To do assets, scripts, RPC. Let's do, for example, admin node info. And that should call the RPC endpoint and give us the information about your node. So you can see the node address of the port, you can see the name it shows to other peers when it connects to them, and some other information. We can also check, for example, what kind of peers it is connected to. So for example, we can do admin peers call. You can see several peers here. Let's just maybe make it a bit more verbose. So for example, result node. Yeah, there's a few nodes. So for example, name. Actually, you can do name caps. Yeah, we can see we are connected to 3 nodes of the same version. They both speak Waku 0 and Waku V1 protocols. I can also do like address to see their addresses because on network remote address. Yeah, there we go. And you can also add peers. So for example, there's an admin add peer command. So if you have a friend that is running a peer and want to connect to it, then you can use this command. So for example, if we query for peer in our fleet, like fleet status IAM, and we look for example, a prod let's look for a mail server. So for example, grab this one, and we can add it to our node by essentially just calling admin add peer and then giving it the inode. That should attempt to connect. Now, it doesn't necessarily have to connect because peers can have, for example, limits of connected peers. But in general, if the node is fresh and it's not anywhere near reaching its max peers, then it should connect just fine. Now, as I mentioned, it's very important for your node to have the port, specifically the diff P2P port, which is 30303 by default, open. And one of the ways you can verify that it's open is using the nmap utility. Nmap allows you to scan ports on an IP or a DNS address and check whether the ports are open or filtered or closed. If they're open, that usually means that there's a service listening on the port. If they're filtered, that usually means that the firewall is blocking it, either the firewall of your service provider or cloud provider, or the firewall on the host itself, managed by the operating system. If the port appears closed, then the firewall probably isn't blocking it, but in turn, the service isn't actually listening on the port, so it appears closed. In some cases, it is possible for the firewall to make it look like a port is closed, but that's a rare case. Usually, it would appear as filtered. So we can test that, for example, with one of our nodes. Let's, for example, take this one. Our nodes listen on port 443 because this port is a HTTPS port, which is used by all of the websites in the world. So this way we avoid any suspicion, and our traffic looks like just normal HTTPS traffic to any router. So if someone wants to block it, they can't easily do it by port. Now, you can run the status node listening for the P2P connections on any port, but the 443 is a decent choice. So let's see if the port is open. Nmap requires sudo because it does certain checks that don't require permissions. Let's check this port. Yeah, as you can see, it is open. If we tried some other port that definitely isn't open, we would see that would most probably be filtered. Yes, and it is. And this is one of the most basic ways you can check whether your port is open. The best way to do this is from a different host than the one you're running the node on. Right. Now, the check can work if you do it from the same host, but it depends on how the routing is configured. So the best test is done from a different host somewhere on the internet. Another way you can test whether your node is running correctly is using a utility we have provided in the status Go, which is called Node Canary. And Node Canary essentially connects to the node and makes a simple query to verify that it's working. So it will verify that it can connect, and can verify that it can actually speak the WACU protocol. So in general, it's a better test than just checking whether the port is open. Although Nmap is a good troubleshooting utility to just verify the basics of whether it's open or not. So you can make this utility by just calling make node canary. In my case, it's not built, so let's build it. And it has two main flags, which is either -mail server or -static node. In your case, you care about the mail server one because you're running a node that collects history. Mail server is a weird name, an anachronic name. It's there for legacy reasons. We're nowadays calling them history nodes, but it is what it is. So now that we've built it, we can go into build the node canary, and we can use the mail server flag and provided an inode address, for example, the inode address of one of our nodes from the prod fleet. And we can see that it connects successfully, makes a query, responds to the query correctly, and you can see that the canary exited without any errors. And if your node passes this test, then it's functioning properly, and it should be usable to any desktop or mobile device as long as it's available from the internet. Because if this test works for you locally, that does not necessarily mean that it is available from the internet. It depends on the address that is used in the inode. If this address is something like, for example, 192.168, for example, 01 or something like that, then that's a local host address, and if your test data doesn't work, that does not guarantee it will work on the internet. So make sure you're using your public address. There's multiple resources we make available. As I mentioned, there's the mail server markdown document in the repository. There's also a README file, the config directory, which outlines the syntax of the config file. There's also dedicated README files for the scripts, the makefile scripts for both the Docker Compose and the systemd setups. You can read those. And if you want more in-depth look into the config, there's also in params config.go, which is a Go file that defines all of the configuration that the status Go node uses. And there's a lot of comments there that can help you figure out if you that's what you're looking for. Actually, you can take a brief look at the configuration. So as we remember, we have the configuration mounted at var_tmp status go mail server config JSON, and we can edit that file. And a very basic JSON file that essentially provides the node with its initial boot nodes that help it find other nodes. Some of our fleet mail servers, so we can start receiving historical messages, and also push notification servers, and some static nodes for relaying messages, just for initial bootstrapping. Some other configuration includes things like the listen address for the dev.ptp, the one that should be public. Configuration for the JSON-RPC administration endpoint that should not be public. In this case, it's using 0.0.0.0 IP address because it's within a Docker container. And since it's within the Docker container, it has to be port mapped. Then it has to have a broad listen address like that. If it was running through systemd, the address should be localhost or 127.0.0.1. Some other configuration includes, for example, an important setting which is max peers. If your host is resource constrained, it's a good idea to limit this. Or if you don't care about your resources and you want as many peers as possible, you can increase that. The default is 50. Of course, the location of the data collected by the mail server, and some configuration related to WACU related to messaging. This password is not something you should be changing. This is essentially a password used by all of the desktop and mobile devices to connect. It's actually not necessary anymore. It's more of an anachronism left over from Whisper, but we still retain it for legacy reasons. And now, in general, this configuration should not be changed, at least not unless we tell you to. These defaults are sane and should work fine. If we find out that there's a need for a config change, or if we roll out a new version and that requires a config change, we will contact you and explain how to do that. But for now, this should work just fine. Now, if there are any questions, I'm happy to answer those in the chat. Oh, there's a lot of Korean people. I don't think I can respond in Korean. That's fun. Mostly Korean. Well, if you have any questions, I can respond in English, but if it's just Korean, I'm afraid I can't respond. No? Okay. Well, if there's no question, I'm gonna end this. We do have the hash support chat, and also hash node runners or no status node runners chat, where I'll be there and responding to any questions you have. So if you need help, just go into status node runners public chat. I'll be happy to respond in Central European hours. Otherwise, well, I'm sure there'll be other people helping there, but I'll probably be best to respond to any technical queries. Okay, thank you very much.